Okay, so now we are looking at. Okay, yeah. Okay, so today we will be doing polarization. Polarization is basically um, defined as, let's write definition, that when a wave is made to oscillate in one plane only, this wave will be called plane polarized. Alright? Now I want you to understand is that polarized, or in fact let's write polarization, can only take place for transverse waves. Alright, doesn't take place for anything else, so do remember that. Okay. Now what happens in a polarized, unpolarized, like how do you polarize? You just need to remember that. So generally, when you look at any wave, so it could be vibrating in many planes like this, right? And basically, it's like, suppose it's coming like here, okay? So it's just vibrating. So the waves could be generally EM waves or something like that. They just look like, there's a wave like that, and then there is a wave like this. Oopsie. Wait a second, please. So it could be, it's like this, right? So it's like on different planes, it's like transferring energy. But what you do is you actually place a Polaroid such that like that, such that when this wave basically crosses this Polaroid like that, so let's say this is the Polaroid, it basically only lets the part where the slits are, like it's like vertical, so it will allow the vertical part to just pass, and then it will cancel out all others. So now what it has done is that it has caused it to be polarized in the vertical plane and just cancel out everything else. Is it clear, everybody? Javeria, how are you? Do you understand this?
Yes, sir.
Okay. Hamad, what do you say? Okay, so we can write about
थोड़ा
this.
थोड़ा समझ में आ रहा है.
Okay, so basically what it means is, if you look at this part, right, Hamad, it's actually like vertical. So it's like a filter, sort of filter, that only the vertical side of the wave uh, can pass, but the rest of them, which are not exactly like this, cannot pass like that, right? So what I'm saying is a wave can be like, it can be like this, it has a different plane, and then it also can be like, you know, like going in a different plane. Do you understand? So wave can be in different planes. Now, if you place a Polaroid like this, which only allows vertical passing, right? Just a window sort of thing. So what happens is that now only, like, it will cancel out the green one because it's horizontal. So it will only allow this one to pass because it's just like it's vertical that way, so it can let it go. Rest of them, it cannot let it go. Understood? Something like that, right? So this is what polarization is. So what I'm now saying is that when you draw this, you say, okay, um, let's write about it. We say when an unpolarized light passes through, like for example, this one is unpolarized light because it's not like it has vibrations in all directions, in all the planes. So in this case, I'm just talking about this case. The vertical will only pass through the vertical slit, and others will be blocked. So that's what we need to understand, okay? So even so, that if we analyze the vertical ones, let's suppose this is where the wave is going. So it's the particles are vibrating this way. So now we have vertically polarized wave. So which basically was passing, like it is passing from the vertical plane, as you've seen before. Okay. So when like you turn like this thing, if you turn this at 90 degrees, so now the slit will be like this, right? So what we've done is we have actually made a 90-degree turn to the filter. So what happens is you will see no wave is seen as it is completely blocked. So if you notice, the Polaroid, which is now horizontal, like here, it won't allow the vertical side, so it will just, you know, just block it because you turned it to 90. So it will, if you again turn it to 90, so it will allow the vertical polarized light to go, otherwise it won't. All right, Aman, do you understand this?
Yeah, sir. Sir, what if we place another, it's vertical, but it's in front of the horizontal wall, and then again we cannot see any waves, right? Because they are not passing through the horizontal, so how they can pass
Yeah.
through the vertical?
No, what I'm saying is we're not, uh, we are not basically placing another one. These are the same things, okay? So this is like I'm talking about position 1, where the angle to the wave is 0 degrees, and this is the position 2. So this is the same one. Like if I rotate the same one 90 degrees, it's gonna block the whole thing. Do you understand?
Yes, sir.
So they're not two. Don't worry about that, okay? All right. So this is just sometimes these things they're also called analyzers because we analyze what type of wave is coming, right? That's why it's vertically polarized or not polarized or something like that. So you can always rely on this like that. So how do these really how do we create a Polaroid which can filter out waves like this? So let's quickly write that. How to create a Polaroid. So Polaroids are basically made up of a transparent polymer material. Polymer is just man-made, okay, plastic type. It has long chains of molecules all aligned in one particular direction, okay. So basically when the waves pass, the waves are blocked which transfer, because there needs to be energy, right? So transfer energy into heat to these molecules. That's what I'm saying. All right. Now the thing is, what are the uses then? One of the most common one, right, is number one, sunglasses. So if you get the real ones, like really expensive real ones, which has a Polaroid in it, so you might see that basically what sunglasses are, that they absorb vibrations in other directions, like it just makes it plain, to reduce eye strain and glare. That is the reason when you go to maybe base camping, some mountain or something, or you go to beaches where water can quickly just cause huge glare of light, and then also snow, which may cause snow blindness. So you have to use very good ones, good Polaroid sunglasses, right? So that's why we use that. Then the other use for them is that we also use it in cameras nowadays. Use these to take photos with less or no glare, right? So these days cameras are getting better and better, they use that. And one of these things which can also be used in 3D movies and television. So if you know that to watch a 3D movie you have to put sunglasses, right? Oh no, glasses, not sunglasses, just glasses. Basically those glasses have two sides to it. So there's a filter which only allows light of vertical plane to come in, and then there's another one on the other eye that allows horizontal and the vertical. So basically what happens is that one eye of your movie is basically looking at a different movie, and one is looking at a different movie because the other ones are getting blocked, and then they create a depth effect because of that. Do you understand this? That's how it works. Okay, now the point is that these are pretty simple things. We just need to know not to really worry about that. But what we need to know is Malice's law. Malice's law is basically says that when theta is 90 degree to polarized light, no light is transmitted. So just that we have just learned this through the drawing as well, just above. And it says when theta is 0 degrees to transmission axis, I'm just going to explain what these things are. Light can fully pass through. Okay, now what I want you to understand is that suppose you have a source of light, which is polarized in a different kind of way. Like it's not vertical, neither it is horizontal. So it's like this. And this is the intensity here is I naught. I'm going to explain that too. And now you have put a Polaroid, you have put a filter like this. And that filter has a transmission axis like this, right? So it's a sort of vertical filter. Let me just move it a bit. It doesn't look very nice to me. Okay, like that. Okay. So because this particular wave was not exactly vertical, nor it was exactly horizontal, so it will only allow the portion of the wave which is vertical, and will cancel out the rest of it. As you can see now, it's become vertical, but the thing, it only allows that particular portion, right? So it is causing a different density to come back, right? This axis that you see, this is basically called the transmission axis of Polaroid. So if I look at the wave, like by the way, I'll just write this as well. I naught is the incident intensity, and I is the transmitted intensity. Okay, now let's look at this in detail. So this basically, if I zoom it in and look closely, so transmission axis looks like this, and the wave that we're looking at basically was like this where it entered, right? So we're going to look at one of the portions as well. So the idea behind this is that only the portion which is vertical, it will allow only this much of light. It won't allow the rest of it, which is the horizontal one, right? So this makes it 90 degrees. This is the angle to the axis, like theta. So currently it had amplitude, let's suppose A. So if it has an amplitude A, then we can say, right, then this would be like, this is the base, this is the adjacent, so this will be A cos theta. Do you guys understand this? All right. Now we know that intensity, we have studied it before, the intensity is proportional to amplitude squared. So the new intensity, like for example, if this was I naught and it was A naught, so this is, let's suppose A naught, something like that. A is the intensity of like the maximum amplitude. So what I need you to understand is that basically the new intensity will be equal to whatever like this one is, right? So it's going to be let's say, let's write it this way, like I told you, I1 over I2 equals to A1 square over A2 square, so that's the ratio. So the intensity was I when it just entered, which was I naught, and the amplitude was A, so square, okay, like that. Now I want you to basically, the new intensity is I and the new amplitude is A cos theta whole square. Do you guys understand this? Now I naught over I will be equal to basically A square over A square cos square theta. A square and A square cancels out. So ultimately from here you get I equals to I naught cos square theta, and that is the Malice's law. Is it clear, everyone? Please let me know if you do not understand this. Okay. Now, so it is just a relationship of amplitude. So that particular amplitude that's cutting, right? So basically, it will only allow the portion of the amplitude that is parallel to the transmission axis. It will not allow one that is perpendicular to it, and that's what we need to be very, very careful of. Generally, you just need to, remember this formula and we'll be good to go. So just to see, because it is a cos square function, so we can actually draw this. It's pretty simple. So if I draw the intensity curve, I would like to tell you that we have intensity in watts per meter square, and here we have theta in degrees. So you have 0 degrees, and then you have 90, and then you have 180, and then you have 270, and then it's 360, like that. So you just need to remember that at 0, it will show you the maximum intensity, but as it reaches 90, it will, because the intensity will start to decrease, because you're basically, it's blocking it. At 90 it will be 0, and then at 180 it will be maximum again, because it's the same angle, 0 somehow, like that. At 270 it will be 0 again, and so on, like that. Is it clear, everyone? So
Yes, sir.
it's just that it blocks at 90 and its multiples, and it lets it go from 0 and its multiples, like that. Okay. Okay. So first of all, we're going to do 2 questions. Okay. And see if you guys can manage that. And then we'll do a past paper question to see how they gave it last year. And hopefully you'll understand. Okay. Now, wait a second. This is the question. Now, in this question, it says plane polarized light of intensity 12 watt per meter square is incident at a Polaroid. Calculate the intensity of when the angle between transmission axis and incident light is 45 and 60. Can you guys do it, please?
Sir, is this 48 or 45?
45. Okay, you guys got an answer?
Sir, for 45, I got 6, and for 60, I got 3.
That's correct. So you just need to use the same formula. You got to do 12 cos square of 45. So if you do not know how to take cos square on your calculator, so I just want to tell you that you take as a whole, like, let me show you how to get this. So it is like 12 times, you take bracket open, you say cos of 60, suppose, and then you take like bracket close, whole square, so it will become like this. So you just need to take the square of the function, not the cos separately. So that's what you need to remember. Okay, that's one thing that I want to tell you. And now the real question basically is this one, which is like the plane polarized light is incident at a Polaroid. Calculate the angle theta which gives transmitted light intensity 30% that of incident intensity. So if you do this, I'll be quite happy that you understand this. Okay.
Is it 56.7?
56.7. Yes, that's correct. Very good, very good. So to do this, you guys need to understand that it says 30% of light. So the incident light is 30% of the original, transmitted light is 30%, which means that transmitted light is 0.30 of I naught. So when you write the formula, cos square theta, this will be 0.30 I naught, cos square theta, this will cancel out. So cos theta will be basically root of 0.30, and then you take cos of inverse of this, so you should be getting like 56.8. Okay, done. Okay, if you have any questions now, please let me know. I would love to, tell you what it is. So that would be it from this chapter. All right. Okay, so I think I will see you in the next class then. All right, and have a nice day and chill. All right, so we'll start the next topic from tomorrow. Bye.
Bye, sir.
Office.